The most generically applicable measurement in process management is lead time. So in this feature overview of Agilon Process Intelligence, we'll take a look at how you can use our lead time analysis function to dig into any deviations and improvement opportunities in terms of the end-to-end or specific interval lead times in your process. You can get a pretty good overview about the different lead times already in the process discovery step. So if I zoom in on this chart, we can see the average lead time for any flow between two different events in this process chain. But what about the scenarios when I want to track the lead time between, for example, the creation of the sales order and the actual delivery to the customer? I can't really see that in that kind of visualization because there are intermediate steps here. So that's where our lead time analysis functionality comes in, and what that allows you to do is select any sequence of from and to events and analyze what is the average lead time and how does that deviate between different attributes and deviations and variations of this process. The lead time analysis works in a similar way to the regular analysis in Agilon in that I select the scenario I want to analyze and I will get an analysis over all the various different attributes in this model to see which ones contribute positively or negatively to this outcome. So from a lead time point of view, of course, the scenario I select is which lead time do I actually want to measure. And this can be calculated based on all the different events that are available in the model. So what I do is I select the first event from which I want to start my lead time calculation, and then I select the event that is the definition of when I end my lead time calculation. So in this model, if I want to see the logistical lead time, I can select carrier pickup as the first event, and then I select the actual time that this delivery reaches the customer as the later event or the endpoint of that lead time calculation. And then I will calculate the average. I say that's slightly over 9 days. I can also then choose which attributes do I want to analyze this by. Starting off here, I've only selected to look at the seller state, so the state that the actual seller in this case is based in. So that's my input in terms of which attributes I want to analyze by. And what Agilon will do then is go through each and every value, each and every state that we have actually sold something from in this data set. It would show how many order lines do we have for each and every state in this case. And it would show me what is the average lead time for this specific state. And then calculate the deviation between the lead time average for that state and the general average. So then I can see for each and every state in this case, how much longer or shorter is the lead time compared to the average in this data set. And now that allows me to also sort based on this. So if I want to see which state has the largest lead time deviation, I can see that it will then rank the states based on how much they deviate from the average. But an important factor here is, of course, that we also have some states with very few order lines. So yes, we may have a large deviation in this state, but we also have one order line. So that's where the impact attributes come into place. And what that does is basically it multiplies the deviation in lead time with the amount of orders to get the total sort of impact of how much delays this deviation is actually causing us. So then I can sort by that measure and see specifically which states do we have the largest problem in terms of lead times causing us actual overruns on our end-to-end delivery time. At this point, I'm only running the analysis across one attribute, but the beauty of analysis in Agilon is that I can simultaneously run this across any number of attributes from the model. So if I also add the customer state, for example, we can see if that's an attribute that has more impact on the lead time deviation. And it turns out it actually is. So the top 4 ones are actually more related to the customer state or the endpoint of this process in this case. And I can keep going and adding as many attributes as I like. This analysis will always take into account which specific value among these selected attributes is the one that has the largest impact on this deviation. This analysis already gives us a lot of power to look at lead times, but we can still take this to the next level by selecting specifically what we want to compare the lead times against, not just the internal average lead time in this case. and specifically select how we want to calculate the impact. So in this scenario, we're looking at the number of days, but we might also want to measure that in terms of, for example, the order value and the total capital binding. So let's move on to the lead time benchmarking tab to see how that works out. In benchmarking mode, I'm no longer comparing to the internal average. So instead, it opens up this panel on the right where I define my comparison set. So as long as I haven't selected anything else in the right panel, we don't really have any deviations because now we're just comparing one data set to itself, basically. But as soon as I enter something else, like let's say I want to compare the lead time from carrier pickup to delivered to customer for all these product categories, but benchmark them compared to the performance for when we deliver air conditioning. As soon as I select something else, we will have a different average because now we're looking at the average for our air conditioning deliveries, and the comparisons will be state by state. What's the lead time average for all product categories compared to when they're delivering air conditioning units instead? And that's the basis for the deviation calculation. So in this way, I can select any type of comparison scenario, and I can even do that based on the definition of the lead time. So I can compare two different lead time definitions compared to each other. So if we stick with carrier pickup to delivered to customer on the left side, I can compare that to, for example, what's the lead time when the customers pick these goods up themselves. And I can see by selecting lead time from the sales order is created to the point where we have the customer pickup event. And then I can go in and compare the lead time for these two different delivery methods in this case and see in which scenarios does the option of shipping the goods ourselves work out better than the lead time for when the customers come to the warehouse and pick these goods up themselves. So in general, we can see that the delivery time is actually slightly lower in this option where the customer pick the goods up themselves. To rank that, I can of course sort by the deviation calculation to see if there are any exceptions to this, and it turns out there are two states where this is actually not the case. So where our shipping via our own channels is actually faster than having the customer pickup option. And of course the same thing with attribute supply here, so I can do this analysis over many types of attributes at the same time. So if I want to check this by seller state as well, see if that has any effect, I'll just include them in the analysis. Same with any attribute I want to include in this report. Now, I hinted before that we could use any type of measure to do weightings of these kinds of analysis. And a popular option then is, of course, to use the more financial metrics, such as the order value in this case, to see what sort of impact do these deviations have on financial metrics instead. And in this model, we have access to the specific order value for each and every row. And that means we can do some really powerful and useful calculations. Now, we know the total time period that we're measuring over, these 4 years here. We know the deviation in terms of lead time, and we know the order value for the specific line. Putting all of that together, we can actually calculate the net effect on working capital. So this deviation of on average 9 days, considering this order value and this 4-year time period, means we have an average extra capital bind of $8,000 because of this deviation. So now I can sort by this value and see the specific deviations that are causing us the largest net increase in working capital due to this deviation delay here. So what we're looking at on the top row is that for account manager Paul Jones, and he's slightly below 900 orders, if we could get the lead time of shipping those orders down to the average lead times of customer pickup for his orders, we would actually reduce our working capital with more than $100,000 a year. So that's a very powerful way to weight this analysis from a financial point of view and get metrics that are very good at as inputs to the business case to get a very good understanding of how much money can we actually save by getting rid of this deviation. that's it for this feature overview on lead time analysis. If you want to find out more and see how Agilon can help you in your specific scenario, please check out our website, send us an email, or follow us on LinkedIn or check us out on YouTube. Till next time, take care.